Scalars and vectors. Scalars and vectors are types of measurements that we use in science. Now we're used to scalars because they measure how much. Measuring how much, that's referred to as a magnitude. Examples of scalars include distance, speed, time, mass, energy, and temperature. Now these are scalars because they don't include a direction. It wouldn't make sense to say that the time is 3 seconds downward or temperature is 30 degrees Celsius to the north. Those just don't make sense to put a direction on. However, vectors are measurements that include a magnitude, which is how much, also with a direction. Examples include displacement, velocity, and acceleration. These are three vectors we've talked about before in this previous unit. Force and momentum, we're going to talk about forces in Unit 3 and 4, and then momentum in Unit 6. Now these all have directions. It makes sense to say acceleration, let's say for example the acceleration due to gravity is 9.8 meters per second squared downward. That makes sense. A force is going to be 3 newtons to the left. Somebody's applying a force to the left. So it makes sense to put a direction with that. Here we have an example of the difference between distance and displacement. Now we've talked about the difference between distance and displacement when we said that something moves 8 meters to the right and then 3 meters to the left and then 5 meters to the right, and then we talked about how the total distance traveled and the displacement are different. Here we have 10 meters to the right, 10 meters down, then 10 meters to the left to get from where we started to where we ended. Now if we looked at the total distance traveled, we would say 10 plus 10 plus 10 gives us a total of 30 meters. But it wouldn't make sense to put a direction on that because we got right, down, and left, 3 different directions, so the direction for the distance just wouldn't make sense. However, if we look at the displacement is 10 meters downward because from start to finish we go down. That gives us a direction. It makes sense to have a direction on that. We can also call it south or negative y direction. It depends on the context of the question. If we're talking about the vertical plane, then we're talking about up, down, left, and right. If we're talking about a horizontal plane, like in the middle of a field or forest or something like that, we would say north, south, east, or west. Or if we don't know the context of the problem, we don't really know what it's talking about, then we can refer to the xy coordinate system like the positive x direction or the negative y direction here. Vectors are represented with pictures. We use arrows and draw those to represent the vectors, and the length of the arrow refers to the magnitude of the vector, meaning how much, and then the angle refers to the direction. So here we have north, south, east, and west, and then we have our vector, which is a magnitude of 5 meters and an angle of 30 degrees. Now if I had another vector that was 10 meters, I would expect that vector to be twice as long because the length of the vector represents the magnitude of the vector. Now this 30 degrees, we have to be more specific than just 30 degrees because we could have 30 degrees over here or we could have 30 degrees down here, so we have to identify exactly which 30-degree angle we're talking about. And we do that by looking at this quadrant right here. We're in the northeast quadrant. So we have to identify our vector with respect to things that we already know, directions we already know. We know the east direction and we know the north direction. So if I started east and I were to identify where is my vector with respect to east, I would say my vector is to the north of the east direction. I could also say that from north my vector is to the east of north. Now which one do I choose? Well, if I talk about east of north, then I would need this angle over here, but if I talk about north of east, then I would use this angle right here. So we say the displacement is going to be 5 meters at 30 degrees north of east. We could identify this angle over here. I mean, that's pretty simple. 90 minus 30 gives me a 60-degree angle here. So we could say our displacement is 5 meters at 60 degrees east of north, and it would identify the exact same direction. So here we have another vector. It's going to be 15 meters per second, and our angle this time is 15 degrees. So this angle right here, if we look at our vector, we got south and west. We're in the southwest quadrant here. If we start from south, because that's where our angle is, we would say our vector is to the west of south. So the velocity is going to be 15 meters per second at 15 degrees west of south. We could also identify the vector as being south of west, but we'd have to use this angle over here, so it'd be 75 degrees south of west. You may run into a problem with these, and you could do a problem and your neighbor beside you could do a problem and you get two different angles. Sometimes the reason you get two different angles is because one person found this angle over here, south of west, and the other person found west of south. So if you take your two angles and you add them up and they equal 90 degrees, then probability is that you've done it right. You just have the complements of each angle. The vector worksheet we complete in class. The trig ratio worksheet we complete in class. And we're going to talk about the trig ratio worksheets here. Okay, now I have taken the measurements of each of the triangles on that trig ratio worksheet. This is the large triangle, this is the small triangle, and this is the triangle that's in between. I've also measured the angles of theta that's identified on each triangle, and I got 20.1 degrees, 20.2, and 20 degrees. So I got about the same angle on each of those triangles. So they all have the same interior angles, they're just one's bigger than the others. Alright, so I take a ratio between opposite over hypotenuse, and I found 0.3471, and then I do that for each triangle, and then I took the adjacent divided by hypotenuse, and then I took opposite divided by adjacent, and I got these over here. Now if you notice, between each triangle, regardless of how big the triangle was, the ratio between their sides were about the same. For opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So as long as the interior angles are the same, the ratio of their sides will also be the same. Alright, so that's what we get here. Regardless of the size of the triangle, if theta is identical, meaning the interior angle that we're looking at is identical for two triangles, right triangles, then the ratio of their sides will be identical as well. And then we give these ratios names. Alright, so opposite over hypotenuse we refer to as sine of the angle, theta. Adjacent over hypotenuse is cosine of the angle. And then opposite over adjacent we call tangent of the angle. Alright, so here we have the 4 steps for solving word problems, and we've talked about these 4 steps before. The first one is to figure out what we know, the second one is to figure out what we're looking for, third step is to figure out which equation gets us from what we know to what we need, and then the fourth step is to solve. We're going to use these steps in order to figure out how to find sides of a triangle or even the angle on the inside of the triangle. This is going to be important in order to help us with vectors. Here we have this acronym to help us remember which trig function goes with which ratio. Everything is with respect to the angle. We got opposite, adjacent, and the hypotenuse is always the longest side and opposite the 90-degree angle. When I was student teaching, I also had my mentor teacher give me an alliteration to help me remember SOHCAHTOA, and that's some old horse caught another horse taking oats away. If SOHCAHTOA doesn't help you, then maybe this alliteration can help you. So SOH stands for sine of the angle equals opposite over hypotenuse. CAH stands for cosine of the angle equals adjacent over hypotenuse. And then TOA stands for tangent of the angle equals opposite over adjacent. Now these trig functions are like any other functions that we have or operations that we have, like division or delta or things like that. We have to have a variable or something with it. So we wouldn't just write sine equals opposite over hypotenuse. We'd have to say sine of the angle. We have to have an actual number here. Like with delta, we would have delta x or delta v. We don't just have delta by itself. So make sure you include the angle when you're writing your trig function of the angle equals opposite over hypotenuse or cosine or tangent. Also, we're going to use a Pythagorean theorem. We have a squared plus b squared equals c squared. Pythagorean theorem doesn't matter which side you identify as a or b. These can be switched and you still get the same answer, but C always has to be the hypotenuse. So A and B could be either of the two legs, but C always has to be the hypotenuse. Here we have some examples. We have the hypotenuse, which is 5 meters. We have the angle, which is 30 degrees. So that's the information that's given to us. We're looking for x, the opposite. So looking for the opposite, we have the hypotenuse. We're going to use sine of the angle. So sine of 30 degrees is going to be equal to the opposite, which is x, over the hypotenuse, which is 5. We're going to multiply both sides by 5 in order to get x by itself. So x is going to be equal to 5 times sine of 30. Punch sine of 30 into your calculator, you get 0.5. 5 times 0.5 gives us 2.5 meters. Now we know it's meters because the hypotenuse was also in meters, so the measurements are going to be consistent for the legs of the triangle along with the hypotenuse. This next example, We have 8 meters per second. That's going to be opposite the angle. We have the angle itself. It's going to be 50 degrees. And we're looking for the adjacent. So opposite, angle, and adjacent, that's going to be tangent. So tangent of 50 degrees is going to be equal to opposite over adjacent. That's 8 over x. So we need to multiply both sides by x in order to get the x out of the denominator. So x times tangent of 50 is going to be equal to 8. We're going to divide both sides by tangent of 50 to get x by itself. You punch tangent of 50 into your calculator, it gives you this number right here, this 1.192. So 8 divided by 1.192 is 6.71 meters per second. So the adjacent is going to be 6.71 meters per second. And we know it's meters per second because that's consistent with the other side. This next example, we have x as our hypotenuse and we have 4 as our adjacent of the angle. So adjacent and hypotenuse will give us cosine. We got cosine of 40 degrees is going to be equal to 4, my adjacent, divided by x, my hypotenuse. Now we need x in the numerator again, so we're going to multiply both sides by x, but we need our variable by itself, so we're going to divide by cosine of 40 degrees. Cosine of 40 degrees, punch out in your calculator, you get 0.766, so 4 divided by 0.766 gives us 5.22 meters because that's what we have here, so we need to be consistent. Alright, so here we have another example. We got the adjacent, which is 6, and the hypotenuse, which is 8, and we don't know the opposite. We don't know the angle either. So if we have the adjacent and the hypotenuse, then we're going to use cosine in order to figure out the angle. So we use cosine of the angle equals 6 divided by 8. Punch in 6 divided by 8 in our calculator, we get 0.75. Now we have cosine of the angle. Our angle is our variable, so we have to get rid of this cosine trig function somehow. Well, if you take 2, let's say we multiply by 2, how do we get rid of that? We divide by 2. If we square something, to get rid of that, we square root it. To get rid of adding 3, then we need to subtract 3. These are all called inverse functions of each other. Multiplication and division, multiplying by 2, dividing by 2, are inverses. So we have cosine that we need to take the inverse of in order to get our variable by itself. So I'm going to take the inverse cosine of both sides. Now the inverse cosine, it's also called arc cosine. Arc cosine of cosine cancels those two and just leaves me with my variable. But what I do to one side, I have to do to the other side. So arc cosine of 0.75, and we punch that in our calculator and gives us 41.4 degrees as my angle, because cosine and arc cosine, or inverse cosine, canceled each other, left me with just my variable. Now I need to figure out this side right here. Now what I could do is I have the hypotenuse, I have the adjacent, so to figure out the opposite I could use sine of the angle. The only problem with that is that I have a calculated answer for my angle. So if I do sine of a calculated answer to find another calculated answer, then I'm going to get a lot of rounding error. To avoid that, I'm just going to use the Pythagorean theorem. X squared plus 6 squared is going to be equal to 8 squared. 6 squared is 36. 8 squared is 64. Subtract 36 from both sides, and I get that x squared is going to be equal to 28. Square root both sides of that, and x is going to be equal to 5.28. I'm sorry, 5.29 meters. Meters because the other two sides were in meters. Alright, so we have another example. We have the opposite, we have the adjacent. We're looking for the hypotenuse and the angle. Well, first let's do the angle. We have opposite and we have adjacent. So opposite, adjacent, we're going to use a trig function of tangent. So tangent of the angle is going to be equal to 3 divided by 6.5. 3 divided by 6.5, punch out in your calculator, you get 4.62. Inverse tangent of both sides, so tangent of theta, inverse tangent of that will cancel that, but what I do to one side I have to do to the other side. So punch in your calculator inverse tangent of 0.462 and you get 24.8 degrees. Now to find this side, the hypotenuse, then I've got these two, a and b, so I take a squared plus b squared, so that's going to be 3 squared plus 6.5 squared is going to be equal to my hypotenuse squared, which is x squared. 3 squared is 9, 6.5 squared is 42.25, and x squared, we add those together, we get 51.25, square root of both sides. And that gives us that x is going to be equal to 7.16 newtons. Now, newtons is not a unit we've really talked about because it's a unit of force, but capital N refers to newtons, so the hypotenuse is going to be in newtons.